there, it's Strayus, and today I want to talk about dark matter. So a lot of this stuff that I'm going to be talking about comes from the NASA websites, Wikipedia, of course, and then cosmography.com. So dark matter. So I've been thinking about this recently, partly due to one of my last videos where I was talking about theories of ghosts and how maybe dark matter could be linked to what we think of as ghosts. But while I was also thinking about this, my dad brought up to me that he saw somewhere that dark matter, there was proof that it's not a thing. And so I didn't believe him because, well, you'll understand why once I explain what dark matter is or isn't. And so I started to do kind of a deep dive into it and really to understand what dark matter is, how we're trying to research it, and how it interacts with the universe. And I found, I think, the article that he was trying to talk to me about. So let's get into it. So, dark matter is a form of matter, and it accounts for about, well, it depends on who you ask, but most of the things that I found is about 85% of matter in the universe. And the rest of it is made of dark energy, and then of course about 5% is the actual matter that we can see around us today, like what we're made out of and what my camera is made out of and that kind of thing. When I was first diving back into it, it's been, I guess, about exactly a year since I started learning about modern physics in a classroom and talking about dark matter at all. And so I was getting back into it and going through some old textbooks, and I remembered for some reason my brain kind of connected antimatter and dark matter together, which I think is a pretty reasonable thing for someone who, you know, if you haven't really had a lot of research into dark matter, which I had a semester where I think maybe like a day or two of class was focused on dark matter and the subject. So I wanted to talk about how they're different. So dark matter can be confused with it, but antimatter is essentially made up of particles that are antithesis of particles that make up like ordinary matter. While dark matter has not been observed directly, but kind of indirectly, antimatter has actually been generated in a lab using particle accelerators and cosmic ray collisions and some radioactive decay. It's also observed in that. So there's basically the essential difference in antimatter and dark matter. If y'all want to see a video on antimatter and me going more into that, you can totally do that, but today I'm here to talk about dark matter. So that's the difference. Dark matter, we haven't seen it. There's basically, it can't absorb light, emit light, or reflect light, so we haven't seen it, we haven't been able to observe it. We're trying to though. And antimatter, we have been able to observe it in a lab setting. So before I talk about more what dark matter is, I'm gonna get into a little bit of the history of how, when we started thinking about dark matter, when it was not discovered, but originally theorized about. So dark matter and dark energy can kind of feel like conspiracy theories sometimes, mostly because we know so little about them, but the whole scientific community is pretty much rallied around the fact that they exist. While within science you're not able to technically prove something, there is no proof that dark matter exists. So it was first discussed in a talk given by Lord Kelvin, which, yeah, that Lord Kelvin, if you're anything into science, you know that the absolute temperature is named after him. The telescopes that we had weren't advanced enough to be able to see that there were actually galaxies out there, so that at this time we thought we were the only galaxy in existence, and the stars that we could see were all inside our own galaxy, so we thought the universe was a lot smaller than it actually is. But he gathered from observations made in our own galaxy that of the stars and the relative velocities, there must be a great number of dark bodies that to make up for the mass that is not there of the stars, the light bodies that are existing in our universe. So, and a little bit of background on Kelvin. So he was just a mathematical physicist and engineer in the late 1800s. He did important work in the mathematical analysis of electricity and formulation of the first and second laws of thermodynamics. He did much to unify the emerging discipline that is called physics today, which I'm very grateful for because that was my major. So the term dark matter was actually coined later by Henry Poincaré, which I believe he is French, in 1906. So he was also actually just discussing Kelvin's work, and he coined the phrase himself, dark matter instead of dark bodies. In 1919, Edwin Hubble made the discovery that our galaxy isn't the only one. There's more than just our galaxy out there, which means the universe is a lot bigger than we thought. Because he realized that all these different stars that we were looking at, some of them are their own galaxies, which was a huge discovery in the time. He also discovered that redshift is a thing, which I can get into later. And he was just an American astronomer. Okay, and so a little bit later, at this time, there was still not a lot of belief in the fact that dark matter existed. That didn't really happen until the 70s and 80s when people started to rally behind the idea. So in 1932, there was a guy named Jan Oort, or Jan. He hypothesized the existence of dark matter. He was studying stellar motions in the local galactic neighborhood, so near us, and he found that the mass of the galactic plane must be greater than what was actually being observed there, in that what he could see with his own eye through the telescope, there should be more out there than what he is actually seeing. So he actually decided that this measurement that he made was just not important, and he kind of dismissed it. Didn't question it any further, didn't really go back into it, which turned out to be a mistake, because a little bit later on, dark matter turned out to be a very widely accepted idea. So then we come up to a little bit sooner in the timeline. So about 10 years ago, there was a lab set up underneath the Earth in South Dakota to try and detect these dark matter that we have. And in 2017, there were observations that caused scientists to believe that dark matter actually exists in long hairs or filaments. In 2018, there was this galaxy that they observed to have much less dark matter than expected. The galaxy in question had about 400 times less dark matter than they expected to have, given the size of the galaxy, which basically means that it was moving a lot slower than than would make sense for the size of the galaxy. So other galaxies in the same size range were moving a lot faster, meaning that they probably had more mass given the dark matter. So since this galaxy is about the same size and it wasn't going as fast, they determined that it had a lot less dark matter, which they tried to figure out why. And I think this is where my dad was getting at, that he was thinking dark matter doesn't actually exist because they were unable to find it in this particular galaxy. And it could have been a clickbait article. So astronomers have actually been scratching their heads about this particular galaxy for a long time, for those whole 3 years after they found it. And it was actually in 2020, just last year, that they were able to realize they think they know what was going on. So there was a discovery made that it was probably tidal disruption that was causing a lack of dark matter, which essentially means that at one point the galaxy did have the same mass of dark matter that the other galaxies of the same size had, but it had been being stripped away. So being able to realize that it was actually tidal disruption, which means basically the dark matter was being pulled away from the galaxy, is a big relief for the scientific community, because I think for those 3 years they were trying to grapple with the idea that our laws of gravity and how we think the world works, the universe works, we're having to rethink it all. But in actuality, we don't. It was just that the dark matter was being taken away from this galaxy. So one of my questions when I was thinking about dark matter was like, the essential, is it around us? Is it here on Earth? Can we just not see it? And the answer to that question is probably. They actually have multiple labs under the Earth in all different countries that are weighted down in like old mines and that kind of thing. One specific one that I looked into, and it's called SURF, Sanford Underground Research Facility in South Dakota. And because it's so far underground, the experiments can be shielded from any background radiation that we have here on Earth from the sun and everything else that we have. So it's so deep in the ground that it's able to be shielded from all that, so that way they can isolate what they find and determine if it is from dark matter or other things. They don't have to deal with all the other noise in the background. So the way that they're actually trying to detect it down there is they realize that this, if dark matter exists, then eventually it has to bump into ordinary matter. And when it bumps into this ordinary matter, it's going to cause vibrations. So they have very high-tech equipment that is basically just looking for bumps, vibrations. That is kind of essentially like the easiest way to describe. So there's different types of metals and different types of chemicals that they're using to be able to determine if there is vibrations within the detector. And then by doing that, they're able to try and capture what they think would be dark matter. So now onto what dark matter is. So the reason we haven't been able to observe it, like I said earlier, is because, you know, it doesn't really interact with light at all, which means it can't really interact with our eyes, but it also doesn't really interact with any of the other equipment that we use. The reason we think dark matter exists is because of the gravitational pull that we are observing on different galactic bodies. So the gravitational pull, if you look at a equation for gravity, you'll see that mass has a big part in it, but also the acceleration or the velocity that it's going at and the change in velocity. So those are all factors that go into it. And when we observe something and we're able to see kind of how big it is, the radius of it, and factor that into our equation, and we see that it's going pretty fast and the size of it, it doesn't make any sense as far as like the mass that we can calculate for it. We realize that we're missing a big chunk of the mass within the body, and the way we are trying to reconcile this is by calling the missing mass dark matter, something we can't see. So if dark matter wasn't real, we would have to rethink everything we've already found about gravity, about how the bodies in the solar system are working. All of our fundamental physics stuff would have to be completely rethought if dark matter isn't real. So essentially that's what it is, or what it isn't. It's very confusing, but it's fascinating because there is something that we can't see, we can't feel, smell, or hear, but we know it's out there. And the whole scientific community believes it. So that's why science is so cool. There's so many things out there that we don't know. And I can't wait to try and figure it all out. We're learning more every day. Who knows? Maybe tomorrow they'll find out that they were able to detect dark matter and this video will just be kind of pointless. So we'll see. Let me know what you think in the comments below. I was about to say dark comments below. Yeah, the dark comments below. Let me know what you think. And that's what I'm into this week.